Hello everyone, welcome to my channel. My name is Chandrachud Chatterjee. I am a MTech student at IIT Madras. So this will be the third video in the tutorial section of machine learning. So the first two videos are already posted on YouTube, and this will be the third video following the second video that was on linear regression. So in the first video we went understood how a simple SVM model can be used for the iris dataset, and in the second one we saw a linear regression example, how to use simple linear regression for a simple continuous valued dataset with just one in feature vector and one output vector, which also contain continuous values, right? So in this video what we will do is we'll try to develop a model, again an SVM model on a particular dataset, which I will tell in just a few minutes, and then we'll see how we can develop an application, or let us simplify it to an web application using simple HTML and a Flask tool provided by Python, so that we can actually use our model for real-time prediction, right? So this the intention of this video is to make the machine learning topics more interesting, more actually practical, and let us so that we just have a little bit of detour from the mathematical formulas and concepts and probabilistic models and statistical models. So in this whole tutorial I will try to make the all the videos more accessible to laymen, and describe them as much as possible in layman terms, so that people who do not have much background in intensive coding or programming or intensive concepts regarding machine learning can also have an idea and have interesting thoughts about how these machine learning models are actually being developed and are actually being used in the industrial level at various real world applications, right? So as you can see, I have actually opened the collab file and named it gender classification. The name is very obvious, and we will also understand why I have named gender classification as and when I show you the corresponding dataset, right? So first of all, we will see the dataset, but first let us mount the corresponding drive. Let us see if the drive is mounted. Okay, so I have already mounted the drive. How to mount the drive is actually present in my previous video about the linear regression one. You can just go through it. It is very easy. So after I have mounted the drive, let us have some imports which are very important. NumPy, very important import. I have explained why it is used in some of my previous videos, probably the first one. You can go through it again. You will also import sklearn.svm. We'll actually import from sklearn.svm. So we should have sklearn. So let us use these imports first, and we will see how many we can use, and if we require more, then we'll import as we go along, right? So let us run this. It has run. So now let us try to import the dataset and see what it looks like, right? And why I have named the corresponding collab file gender classification. It will be very clear. So to copy the path, I will go to the data and simply right click and copy the path present in gender classification. This is the CSV file. Let me copy the path. Now let us print it so that you can see what the CSV file looks like. So this is what the CSV file or the data looks like. It has 7 features here, as you can see, and the corresponding class, that is the gender. Gender will be either male and female, and the 7 features, as you can see, are whether the person has long hair or not, what is the width of the forehead, what is the height of the forehead in centimeters, is the nose of the person wide or not, is it long or not, whether the lips are thin or not, right? And what is if whether the distance from the nose to lip is actually long or not, right? So these are the 7 features. As you can see, most of them are binary features except two, the forehead width and the forehead height, which is continuous features. So it does not provide any problem to that. We can easily handle that. And the gender is actually a binary feature as well, binary values as well, male and female, but we will try to convert it into 1 and 0s so that it is easier for our model to actually understand, right? So I think for that we have to import from sklearn dot processing. Will import label encoder, right? So as the name suggests, it will actually encode the corresponding values, male and female, male and correspondingly female, into 1 and 0, right? So let us do that first. So first of all, we call the object of label encoder as gender, right? Now what we will do is gender dot fit will fit the gender column of the dataset, right? And then we can easily replace the gender column using transform function on that particular column itself. Let me execute it. There is an error. Label encoder has no attribute. I have spelled it wrong. Let me change it. Now let us print the data frame and see what it looks like. As you can see, every feature remains same, but the gender has been changed to 1 and 0s, and you can see that the male has been converted to 1. So the male actually label corresponds to 1 and the female label corresponds to 0. We have to remember it because when we will be using it in our application, we do not want to just predict it as 1 or 0s. We have to predict it as male or female so that people who are using the application understand more, right? So that there we will actually be using this 1 and 0s to actually identify whether it is a male or a female, and print correspondingly male or female instead of just the values 1 and 0, right? So now the data frame is actually ready. Okay, we will just split it into the corresponding features and the corresponding labels. So as I have already shown, splitting is very easy using the ilog function. We'll use the ilog function, and now we'll be splitting it from 0 to, I think, let us count it, 0 1 2 3 4 5 6, so it will be 7, and y will be last one, right? Let me execute this. Now let us print x and print y. So as you can see, the x has been converted to the only the feature data frame, and the y is actually the label data frame, or the only the gender column of that particular data frame, right? So we'll do x is equal to x, or we'll do np.asArray to convert it into an numpy array so that our model can actually process it, and we will pass x. And similarly, y will be equal to np.asArray. Now if I execute y, you can see it is simply just an array of binary and continuous values. The two features, as we have mentioned, the width and the height of the four are continuous values, except all other five of them are actually binary values. And simply if you print the y, you will see that it consists only of the binary values, the gender, male or the female, right? So now we'll use the trend test split. So for that we have to import again. I think it is present in model selection. Let me see that. Yes, so now we'll use that. We will have 30% for test data and First of all, let me pass the x and y values, and then we can have the test size as 0.3, indicating 30% for test data and 70% for the training data, right? And we will have stratify over here because we are doing classification, and it would be helpful if you use stratify. We will be stratifying it based on the corresponding labels. So we will make stratify equal to y, and we will have random state equal to, let us make it 24, right? So now let me execute this. Now let us see what is the shape of the train and test, right? So we'll have dot shape and again dot shape. Yeah, so total I think there were 5001 rows correspondingly, right? Actually 5001 rows. So 3500 are in the training data and 1501 are in the test data. Nice. Now let us develop the model and train the model, right? So what we'll use is, we'll use model as an object for SVC. Then we'll simply do model dot fit. We'll be fitting the training data, so correspondingly x train and y train. So let us run it. Yeah, so I think the model is trained. Now let us make the prediction on the test data, so we can just see what the accuracy is, and then we'll try to show how we can actually use this model or actually save this model and use it in an application, right? So first of all, let me do model.predict, and we'll pass the x test. Okay, so now we have, I think you have imported accuracy score, right? Let us see if you have imported. Yes, we have imported accuracy score. So we'll try to print it to see what the accuracy is, right? We will have the y test, the actual values, and the y pred that we predicted, right? Okay, I think the spelling is wrong. Yes, again the spelling is wrong. Let me copy it from here. Okay, yes, it is wrong. Yeah, so the accuracy is printed. As you can see, it is 96.6% accurate, which is more than enough for just showing or using it in application, right? So now let us try to understand an important tool that we will be using for saving the model, right? It is known as pickle. So we will do import pickle and execute it. And now let us create a file name, right, where we want to save the corresponding model. So first of all, what we can do is, we can actually save the model in this path in the drive as well. So we'll copy the path of the dataset CSV, remove the name of the dataset CSV file, and we can name it as gender classification tutorial dot. Now you can save it in .sav files as well as pickle files. I will be saving it in SFE. It does not make much difference. It is just the way how the metadata or the data of that particular model is stored. So you can use either. Both of them will actually work. So let us execute this. Okay, so now we will use the dump function, pickle.dump, and we will be saving the model, and we will be doing open file name in the write back format. So this is the syntax, right? Pickle.dump, then as the model will be saving the model. So we will use our trained model. So we will use model, and then we will use the open, which is I think a function of the OS library, and then we will pass the file name that we have already created over here, the directory in the drive or your local machine if you are writing this code in a Jupyter notebook or any Python editor, and then we will use the write back command so that the file is actually written, right? So we can actually execute it. After we have executed, we can actually go to a drive and see that there is this. Let us see, this is the, yeah. So if I can expand it, let me see if I can expand it. If I go to rename file, I think you can see the whole name. Yeah, gender classification tutorial.sav, right? So this is actually present over there, or we can go to the drive as well. So as you can see, this was the trial file that I had made previously, and this is the file that we created right now. This is the model file, trained model that we will be using to develop an application, right? So this was all about the model. Now, after the model has been developed or actually generated, there is no problem. We can simply use the model. Okay. So what we will do is we download it from the drive, right? So I have downloaded it. Now we can close this. We can also close the collab. We do not need it, right? So now we will try to see how we can develop an application using this particular model. Okay, so we will see that in the next part of this lecture, how you can use Flask and HTML to simply develop an application, actually usable application, and try to predict whether using the corresponding 7 features that we used, whether the particular feature vector gives us a male class label or a female class label, right? We will see that in the next part of this lecture. Thank you. Welcome to the second part of the this video, where we will learn how to use the model that we actually trained and downloaded and saved using Pickle, as I have already shown in the previous part. And we will learn how to incorporate this model into a simple application using Flask and simple HTML pages, because we will be developing a simple web application, right? So I will not be teaching about anything about HTML. You might go through how to develop HTML forms and all, and I will just simply explain the Flask code that is present over here, and how to use the model into the corresponding class code, right? So this is a PyCharm editor. You can have PyCharm editor, or you can use any other editors to develop Python projects. So there is a virtual environment that is created. As you can see, this is the VNV file. So, and there will be templates folder, right? So Flask automatically checks for HTML pages in the templates folder. So we'll have the templates folder, and we'll have two HTML pages over there, the base HTML and the after HTML, right? So the base HTML, as you can see over here, this is the HTML page, right? So let me move this to the left side. So as you can see, this is the base HTML page, and it is a simple HTML form. Let us see what it looks like, right? So this is what the base HTML file actually looks like. This is a simple form where, as you can see, there are 7 options to enter the corresponding feature vectors that we have already used or seen while developing the model. So this is where people will be entering the feature vectors, and they can simply click this predict button to predict which we have used another HTML page to display the corresponding prediction, right? So let us see what the particular HTML page is. Yeah, so this is what the after HTML page actually looks like. So as you can see, it is not actually working. I'm just running the HTML code on itself to see what it looks like. So there is if data is equal to 0, and if else it is male. So you might remember, when we are encoding the corresponding label for the data set, we use 0 to encode for female and 1 to encode for male, right? So this is what it will actually look like, but this corresponding brackets will not be there, because we will be executing the Flask application. So this will be executing in background, right? And simply it will either show male with corresponding red highlight, or a simple female text with a green highlight, right? So we'll see that, but let us again go to the PyCharm editor to understand what is written over there, right? So this is the PyCharm editor. As you can see, this is the base and after HTML, as I've already shown. Now let us go to the application.py, right? So we'll create a Python file known as application.py, and in the same folder we'll also save the model that we dumped using Pickle, right? So this was dumped in the drive. I downloaded it and saved it in this particular folder. It was named as gender classification tutorial.sav, and I have not changed the name. The name is kept as same. So let us try to understand this application.py file, which is a simple Flask Python program. So here we will simply use some imports, right? The important import is the Flask, and we will be importing Flask and render template and this request functions, and then we will import Pickle, because we will use Pickle to load the corresponding model, and then NumPy, because we will be providing the data as an array into the corresponding HTML page. We will collect the data from the base HTML page, from this form and provide it to the application, which will generate the output, and the output after generating will actually be shown or displayed through this after.html file, right? So let us try to understand the application. So this is the whenever you start the particular let us say web page, this is the first where it goes to dot slash, so it is app.route. Whenever it is there, it will just render the template base.html, so it will just display the base form, right? Base.html form where people can actually provide the value. And now this will use the slash predict. So this is what will actually happen when you click the button predict that is present in the html file, base.html file. As you can see, it is an input type, submit type actually value. So and the value is known as predict. The button is known as predict. So when you click that, it will execute this particular python function. So what we will do in this python function is we will actually request the corresponding data correspondingly, all the 7 featured data, as you can see, which are present in the base.html file and named as a b c d e f and correspondingly I think g, right? As you can see, all these are actually present, and will actually read them into the variables data1, data2, data3, data4 and correspondingly data7, and then we will actually create the numpy array using these corresponding data. And simply, as we use in a collab, as we have already seen how to predict on a particular value, we will simply pass the numpy array in the function model.predict, and then we will return render template the after.html. We will call the after.html file and we will actually pass the value, the predicted value, as the data in that after.html file. Now in the after.html file, as you can see, we have simply provided an if else particular condition, so that if the data that we pass as an argument to this after.html file is 0, it will be female, so it will be printed female and the corresponding highlight will be green. Else if it is 1, it will be printed male and the corresponding highlight will be red, or as in html it is known as the background color dot colon tomato, right? So and then this is the name file to actually execute this corresponding file. Every function or everything in python as well as every other programming language has to have a main function, right? So this is the main, and we have made debug is equal to true, so that even after changing simple things in the corresponding application file, the web page or the localhost page that will be executing or running in the Google Chrome or wherever, what any browser that you are actually using, so it will simply reload on itself, right? So this is the corresponding application file using Flask. So the use of Flask is just to use, so we have used this called the created an object of the Flask using this app, right? So app. So now this is what why Flask is actually used, so that it connects the backend. As you can see, we are using this corresponding function as the backend to read the data from one HTML file and then process it, feed it to the model, and then return the corresponding predicted value to the other HTML file, where we display the corresponding prediction or the output, right? So this is what is the use of the Flask. So now let me execute it instead of making it more boring and see interestingly how it actually works. So I have right clicked and let me execute run app. So it was already running because I was trying it in the background, so I will stop and rerun it. So as you can see, it has run, so it is running on this corresponding localhost. So if I simply click on it, as you can see, this is what the form will look like. So now let us put some values and see what it prints, right? So first question is, do you have long hair? Let us make it 0, indicating we don't have. 0 was for no. Enter the width of our forehead. Let us indicate enter 12 centimeter. Enter the height of your forehead. Let me set 4.8 centimeter. Is your node wide? Let us do yes. Is your node nose? Oh, I have made and named them corresponding node. I am very sorry. It should be nose. Is your nose long? Let us make it no. Is your lips thin? Let us make it yes. Distance from nose to lip is long or not? Let us make it yes. Now let us click the predict button, and you can see it predicts that the corresponding facial features are of that of a male. Now this might not be actually completely accurate. We already have seen that it was 96.6% accurate, and moreover it completely depends on the data and what kind of features we are actually using. Not necessarily that facial features or gender classification, simply whether a face is a manly face or a face has female features that depend on only these features. There are several other things based on which gender classification actually depends. So this is just an visualization or illustration of how a simple ML model can be actually used to develop an application. So you can simply deploy this application in Google Cloud or as well as Amazon AWS, right? And people can actually use it uh, by inserting values and predicting to check uh, how it is actually working. So this is very interesting because this is how real world application is actually developed, right? Real world application involves a lot of backend, which you already saw how to develop a model, and also a lot of front end, because this is very important. Otherwise, or just developing a model and printing how much accurate the particular model is not enough in today's world. In today's world, you have to make the particular model usable, and so that people who do not have any idea about what is machine learning can actually be helped or aided with that particular application that you developed using machine learning concepts and all, right. So this was all about this. So you can go through the HTML files and the Flask file. I will try to upload them in GitHub and share the code in my website. And so let me again change to the PyCharm editor, right? So this is the application file. I have already explained it. So this was all about it. Thank you for sticking with me, guys. I think this video turned out to be a little bit long, but it is worth it because it is very much interesting and it provides an insight into how real world applications are developed using machine learning models, right? So thank you very much, and please do subscribe and do await for next videos, which will be far more interesting, and I'll try to make them more illustrative as we go along, right? Thank you very much.